Welcome and thank you for joining this short slide-free session, the second in a series on data management and managing the data sprawl in many of our organizations. Today, Chris Dearden from Komprise is going to do a very short, informative session on data management. My name is Lee Razzo from Cloud Native X. A very short introduction on that. Cloud Native X is basically a one-stop shop for all things cloud native. We cover content from all things from data management as we are today, data analytics, API security, microservices, products and technologies. And one of the things besides hosting events like this, we also do interviews with founders and executives from the various companies in this area. And coincidentally, the most recent is an interview with Krishna Subramanian, who's the co-founder and COO of Komprise, who you're going to be hearing from today. So with that, I will stop my share and turn it over to Chris, who will cover the topic today, data management. Thank you.
Brilliant. Thanks, thanks, Lee. Let me just get the right screen shared out. Okay, so thanks for joining, everyone. Yeah, in part two, but I'll quickly sort of recap a little bit of part one. In part one, we spoke a bit more about how to get a better understanding of your unstructured data and how we might identify some data that perhaps doesn't necessarily need to sit in that top tier of storage. And identifying it's all well and good, but if we don't do anything about it, we kind of move ourselves back to sort of square one, really. We're back where we started, and that's not really great. You've still got data that's growing at 42% a year, and your budgets aren't keeping up. So you're not actually fixing anything just by identifying the data. And the data that the three different types of data that perhaps don't need to sit on that storage, we decided that we're going to use the acronym ROT, and this is a pretty sort of industry standard acronym, but it stands for redundant, obsolete, and trivial data. And we'll deal with those three different types of data slightly differently. So if we just start with the redundant data, data redundancy is actually managed sort of most initially at the file level. File servers and file platforms have had dedupe built in for a number of years now. It's almost come what would be referred to as table stakes. It's a pretty standard feature. And not only are you going to have deduplication in that primary file platform, but any backups for it are going to be using dedupe as well. So a lot of your redundant data will actually work its way out of the system because it's been deduped. And going slightly sort of out of order here, I'm going to talk more about the trivial data next. So trivial data is data that doesn't really have any business value. It doesn't need to be there. It's either data that is irrelevant, or it's data that is junk because it's sort of personal data, cat pictures, or 10 years ago, Christmas party menus and all that sort of stuff. It's data that really is not adding anything to the business. It doesn't need to be there. And ultimately, the thing that you can do with that sort of data is to get rid of it, to dump it. So once it's been identified, contact the owners of that data, and we can use things like our deep analytics to decide who the owners are and inform them that they need to get rid of that data, put it somewhere else. Preferably, if it's their own personal data, take it home. If otherwise, it's going to be deleted, and that's what happens in a lot of processes. And that just leaves us with the obsolete. I can't spell. The obsolete data. And what are we going to do with it? So obsolete data has got business value. It just doesn't necessarily have business value right now. And it's still, it has some intrinsic use, but not necessarily on immediate timeline. So you still want to have access to it, and you might want to be able to use it in the future. just not now. So that gives us a little bit of a challenge as a storage admin as to what to do. And I was trying to sort of help people visualize as to what the different approaches that they could take and how that could work out in the real world. And this is about the closest that I got. So bear with me a little bit on this, but I really enjoy cooking. I'm a bit of a foodie, and I thought I'd find a foodie example for this. And obsolete data is a little bit like a kitchen, really specialized kitchen gadget, like a pasta maker. You decide that you're going to make fresh pasta one day, and you go on Amazon and go buy yourself a pasta maker, and you make some great pasta. It's really, really, really good. And problem is that pasta maker takes up a fair amount of space. It's quite bulky, and it lives on your, if you try and keep it permanently on your kitchen worktop, that kitchen worktop's a little bit like your tier 1 storage. It's lovely, it's clean, you look after it, but it has a finite size, and expanding that could be expensive. You might need to redesign your kitchen, or you might need to move house and buy a bigger kitchen. So if you're not going to be cooking pasta particularly often, or making pasta particularly often, you're going to put it away in a cupboard. And eventually you put it in a cupboard and you put loads of other things in front of it. And one day you decide, oh, perhaps I'll make some pasta. But then you take one look at that kitchen cupboard and it's got so much junk in front of it, it's going to take you half an hour to be able to clear out the cupboard to be able to get to the pasta maker. And by the time you actually get the pasta maker out, you've left the handle somewhere else. You can't find the handle, pasta maker's not working. You decide you're not going to make any pasta. So if you take your obsolete data a little bit like this, if the retrieval process for that data is not smooth, then the data, like the pasta maker, is just going to gather dust. And it's no longer going to be able to deliver value. And eventually it might just get thrown out or given away. So I thought I'd talk a little bit about the barriers to smooth data access, to be able to have your data somewhere else, but to be able to access it in a smooth way. And I'm sort of specifically not talking about archiving here, because archiving does imply that the data has been put somewhere where you have to go through multiple steps to be able to get at it. But here's some of the sort of things to consider. So offline, and this is the putting that pasta maker into the garage or up into the loft. If the media that you're trying to put it on doesn't have an instant access, then it's going to feel disconnected, because it is disconnected. Now, depending on how you want to, the access patterns for the data that you are moving, if they're quite predictable, then this can actually be quite a viable approach. If you know that you're going to be needing to retrieve your data back in 12 months' time, because it's data that is really important for a week every 12 months, you could potentially use an offline style of media for it, and then be able to recall that proactively, because you know exactly what data is going to be accessed when. Because users don't always have those predictable access patterns, this might not be applicable for all of your data. Next thing I wanted to talk about was agents. So if it requires an additional piece of software for you to be able to access that data, and that software might not be installed, it might not be up to date, it's going to make the transparency of that data difficult. And it's not just users' desktops that you have to push this agent out to. There might well be application servers that need to access the data. And if they can't, then that data is no longer smoothly accessible. We can also talk about the data path. The route to access your secondary data is the same as the route to access your primary data. And there is a process which is working out whether you're trying to access primary or secondary data. And that process is potentially a single point of failure and potentially a point of performance, which means that your cold data is dictating how fast you can potentially access your hot data, and you really want things to stay away from that hot data path. Keep it, if it's not cold, then we really shouldn't be getting in the way of that. Rehydration. So does the data need to be brought back to the primary storage in order for it to be accessible? Yes, it's great that you can push it there and bring it back transparently, but if once it's been accessed, it's now sitting back on that primary storage, then it's just going to fill up your primary storage again. That's not, you're not putting your pasta maker away after you've made it. What if you could make pasta with the pasta machine still in the cupboard? So if you could access that secondary storage directly and use that data and make use some of the value in it by storing that data in a native format, then you're potentially getting the best of both worlds. And the last thing that could be a barrier to smooth movement of data around your infrastructure is independence. So if your secondary tier is dependent on your primary tier, then you could have problems if you want to move either of those, whether that's your choice of cloud provider for a secondary tier, or your choice of storage vendor or storage platform within that vendor. If you want to be able to keep those two tiers of storage separate from each other, again, and try and avoid that lock-in. So how do we address this at Komprise? Well, in the last episode, we spoke about using Komprise to identify the data. And you've seen this graph, the data donut. But once that is identified, we can build up the data management plan. So this is the set of policies within Komprise that we can use to dictate how data gets moved around and what we do. And each one of those plans has a group in it, or one or more groups. And within the groups, you have shares. Each group has a number of possible actions, and the one we're going to talk about is the move action. So within the move action, we have our file that sits on a tier 1 storage. Komprise, once it is suitably aged, and you choose the age for that particular group. So within a group, you're going to have a move policy that says files that have not been accessed for X need to be moved to our second tier of storage, or our target storage. So in this case, this file is old enough to be part of that policy, and we're going to move it to our tier 2 storage. And in its place, we're going to turn that file into a little dynamic link. And now when a user accesses the link, we will be able to stream the data back from tier 2 to tier 1 without having to move the file. The file still sits on that tier 2 platform. It's only until we access that file so many times that it breaches our recall policy, which it helps us determine the difference between hot and cold data, or we proactively decide that we want to bring the file back permanently with a recall job. So this means that we're keeping the data in the right tier. We're not bringing back data to our primary tier too early, and we're not pushing too much out to our secondary tier. Thus, if you do that, you could end up with sort of excess egress charges, because this path, whilst it's very pretty and sparkly, is also quite expensive if that's the cloud provider. Egress charges are definitely something which you have to bear in mind. So I'm going to sum up with a little bit of a one-liner, that effective management of your ROT data can still allow it to add value to your business without being a burden on your budget. keeping access to data on the secondary storage open and transparent will facilitate this. And it's more importantly going to help you maintain an independent and agile view of your storage. So thank you very much for listening. I've been Chris Dearden. You can catch me on Twitter at Chris Dearden, or email me at chris.dearden@komprise.com. Thanks, Lee.
Oops, thanks very much, Chris. And we will be following up this in a few weeks with the next session. So please sign up for the updates and we will keep everybody posted. Thank you very much.